Hi everybody. Today is Monday of 11th of March. What I'm going to do today is I'm going to talk about our Six Sigma programs. Many of you probably are familiar with this, terminology already. In general, Six Sigma is briefly the program that increase yield or the good product from production line. You need to increase that close to 100%. For example, if you produce 100 units of any components and then you expect to be usable for 100 units, that's idealistic. For this one, is going to be is part of my senior class elective course in electronic engineering. The course name is the microelectronic manufacturer, and for this article is quite long. I type it in just about 6 pages, but I'm going to talk very quick, so it shouldn't take more than 30 minutes or less. Okay, let's talk about our defects tale of by Six Sigma manufacturing. As we know, our mankind is that not imperfect, that's the imperfect, and so the work of human. Yes, we strive for the completeness of production process and try to eliminate defects by control the production so well. We reduce the variations of the process to be minimum, and our goal is the completeness. This means no variation, exact repeatability. While we strive for to get a defect to be zero, or strive for a zero defect. The approach of Six Sigma program that are developed by Motorola give the motivation but attainable to reach our intermediate goal for the production interval or interval production. Typical production process is affected from the source of variation. For example, we have like raw material, environment, human input, and tooling wear, of course, and also from another many other things. The cumulative effect of variables of these variables often be the variation of output distribution of the process, which often causes the tail of distribution curve out of specification limit that has been defined. This one may happen because the widen of the distribution curve, that is the standard deviation or the symbol of sigma is higher. Alternatively, is the mean of distribution can shift to specification limit, and of course both changes can happen simultaneously. The goal of Six Sigma technique is to help to design a product that will function as intended, despite there will be some variation of Six Sigma. Sorry, this is not 60 in physical variable and operating. Manufacturing controls studies show that large number of operation lots can be expected. The mean of any characteristics are a given characteristic to have 1.5 sigma variation, and it is clear that the road to the zero defect must involve the product design that manufacturable. In addition to by controlling the process by stringent control process, the challenge of engineering is to design a robust product enough to withstand the shift of distribution mean of plus and minus 1.5 sigma, and still remain or within the specification limit. This one is not lead the process community off the hook. That means we still have problem. Reducing the variation of course make the design to be easier, robust enough, and in some cases it is possible that economical products that are produced before this is not manufacturable. Indeed, it is the combination of the effort that define the Six Sigma approach for production. The Six Sigma metric give a statistical define as the yardstick that quantify the quality level of a product. In general terms, we measure the characteristics of the products in a different unit and assume that there's the Gaussian distribution to determine the standard deviation of the process. If the specification limit for this characteristic is so high or low when compared to the process mean about 6 sigma, that means the defect will not be more than 3.4 part in 100 1,000 or 1 million part. That's we call part per million, or in short ppm. Even there is the shift 1.5 sigma in process mean? A shorthand for the culture of Six Sigma. For example, the characteristic of the product and the process of production is created. We say that this is the Six Sigma. Practitioners often express the measurement in terms of indices. Capability indices, or we call process capability indices, using the symbol CP and CPK. Six Sigma capability is equal to CP. That can be greater or equal to 2.0, and CPK can be greater or equal to 1.5. By way of contrast, the design of product that have the specification width only plus or minus 4 sigma, okay, I'll put this one wrong, will experience the defect 6,210 per 1 million parts that produces from the same production. As the capability level of Six Sigma is to promulgate and turn to be required for everybody, including our seller, frequency, and then the size of the defect that result from variation induces defects will be decreasing and decreasing, or will be less and less. Now let's talk about the ability of the processed capability. The process capability is assessed by comparing the width of distribution characteristic of the output with the width of specification limit that is defined, and that is associated. These relations is indicated by capability index, or CP, and also known as the design margin, where CP is the width of spec, or the area of the design that allow, or we call design tolerance, divided by the process capability, or the total process variation. For the process that has the total variation equal to 6 sigma or 3 sigma for each of process mean. CP also equal to USL minus LSL divided by 6 sigma, where USL is the upper scale limit and LSL is the lower scale limit. For example, for gate oxide semiconductor is defined to be have the minimum thickness of 210 angstrom and target thickness equal to 240 angstrom and the maximum thickness is the 270 angstrom. Assuming that the data of the process divided the thickness mean is the 247 angstrom. Sorry. With the sorry, with the standard deviation of 5 angstrom, then we can calculate for the process capability for these characteristics as following. It means Cp equal to USL minus LSL divided by 6 sigma, right? And then your USL is what? 240, right? This is the maximum. That's become upper scale limit. And then 210 is just like a lower scale limit, or the minimum thickness. And then your sigma is or standard deviation equal to 5 angstrom. And then that gives you 2.0. If you calculate only one side, the capability index is the Cp equal to USL minus target divided by 3, or Cp equal to target minus LSL divided by 3. Actually it should be 3 sigma. Sorry about that. Cp index tells us about the relation between the tolerance, the desired tolerance, and the process width, but say nothing about the distribution mean to be close there. How much will be close to nominal, or the value of target. CPK index yields information about to process the actual process. And also you can write Cp in another form, is the Cpk equal to Cp multiplied by 1 minus k, when sorry, this is supposed to be lowercase k, but it should be the same. And then k equal to absolute value of target minus mu. Mu is the mean, divided by USL minus LSL divided by 2. Okay, this is the mu equal to the mean of our actual process. And then when we use the gate oxide thickness that's given, we get Cpk equal to what? USL minus LSL divided by 6 sigma. That's the actual Cp, right? And then multiply by what? 1 minus k. This is your k, which is equal to our target. The target is 240, and then minus what? X bar, right? The mean, which is the 247, divided by USL minus LSL. That gives you 1.77. So you calculate Cp equal to 2.0 and Cpk equal to 1.77 for the gate oxide thickness. We can say that this process achieves the 6 sigma capability, and we also can conclude that the gate oxide thickness will be out of spec less than 3.4 of every 1 million wafers that produces. Unfortunately, not all characteristics can be measured in the continuous scale. Something is judged to be good or bad. So the concept of Cp and sigma, how Cp and sigma will be used for that kind of situation, because there depend on the continuous data. There's a way. For example, if 2 in 500 competent, not conform to standard for quality, some quality characteristic. We will have a defect rate to be 2 by 500 or 0.004, and the defect rate is in the term of ppm. You need to multiply by 1 million. This gives you 4,000 ppm. Alternatively, we can say that quality use is the 1.0 minus 0.004 or equal to 0.996, and it's fair enough to assume that even our data not continuous, but the variation of the process is continuous. Then we can ask that what is the standard deviation? Is that encompass the 99.6% of the area under the normal curve? If we assume that the area 0.004 is in the one tail of distribution curve, the answer is the 2.65, and then we can adjust to equivalent shift and drift by add correction factor 1.5 sigma to the estimate 2.65 sigma, which will be equal to 4.5 sigma. 4.15 sigma. By calculating one-sided CP equal to 4.15 sigma divided by 3 sigma, that's equal to 1.35. The estimation of the ability tells us that our component is not meet 6 sigma quality, even do adjustment to get the equivalent shifts and drift. Okay, after we talking about the introduction of the sigma, let's see here the usefulness of CP and CPK. To increase the CP as much as you can, we'll use the effort between the design of the product and the process together. The design of product has the goal to increase the tolerance that allow to be maximum for our product. We will successfully work. The design of the process has the target to reduce the variation of the process that create the curve, the necessary characteristic to work that successfully work, and centering the process on the target value. The CP index indicates that the process has ability to repeat. No statements is about centering the process, so cannot predict the fraction defective that occur. CP index or high CPK indicates that the process create characteristic in the specification limit, but no statements about the ability inherent of process more than the minimum value. Maintain the process under control. To have the process capability induced to be accurate and useful, the process has to be under control. The classic way to maintain the process that has been controlled is to use the Short Statistical Process Control, or SPC in short. SPC is created by measure the output characteristic, the specific output characteristic of the process, and determine the result, whether is the meet the specification or not. If so, there will be a calculation control limit 3 sigma, and the process will be sample continually and then compare to the historical distribution. Next one is the 6 steps to achieve sigma. To success in a Six Sigma program, each member in the organization has to understand that the development of the measure quality will attainable and expect in their personal work. We are doing this by 6 process steps that everyone can do it. The first one is to identify the product that we create or the service that we give. It is very important to realize that everybody create a product. Secretary create memo. The design create circuits. Cooks in company cafeteria create meals. The second one, you have to identify external and internal customer for our service or our product, and determine the requirement of them. For example, what they consider the most important. Sorry. Number 3, identify what you need to get the product or the service to satisfy our customer. Number 4, define the process to run our work. Number 5, make mistake resistant process and eliminate the wasted effort. Number 6, make sure that you continue to develop by measure, analyze, and control the process that has been developed. Summing up, okay, the concept of a Six Sigma program give the measurement of quality activities, all of them in the organization, including production, design, market, and administration. The motivation to establish the Six Sigma program at Motorola is to ensure that our customer remain happy with our products while they still in a higher competition environment. For the Six Sigma ability to produce, design the product has to be robust enough to withstand the shift plus and minus 1.5 sigma. In the domain of distribution curve and still in the specification limit, the design of the process has to be results from engineering effort together. That means from the group, the design group, and the production group. We cannot establish the successful of our Six Sigma program without the requirement of our supplier to create Six Sigma. As a result, Six Sigma is the rapidly propagate through electronic community and redirecting quality activities to highly productive. 6 steps to achieve Six Sigma is normal enough that can be used by everybody that do their job. Everybody has product, process, customer, and inherent job to continually development. Okay, so that's pretty much about the introduction to Six Sigma program. Okay, thank you. Bye.